let's go through LeetCode 1462 course schedule 4. For this question, it gives us an integer number of courses in the two-dimensional array prerequisites. So every element prerequisite, prerequisite 0 must be taken before prerequisite 1. Or always say the first element is a prerequisite of second one. And also give us a query two-dimensional array. And for the query, it is asking whether this query, because the prerequisite is transferable. So that means if A is a prerequisite B and B is a prerequisite C, that means A is a prerequisite of C. So for the query, give us those kind of point, asking whether the point 0 it is the prerequisite of point 2, point 1, right? Point 0. The first one point is the second, whether it is a prerequisite of the second one. Because there are a lot of queries, so it lets us to return a list of Boolean. For this question, if we want to find out the relationships between those kind of courses, or we call vertex. So the thing is about is that we create trying to collect write matrix compose based on the prerequisite, trying to compose all of the matrix between any courses, and then we just for the query we just check this matrix. So this will be we can use something called a Florida washer method to write the matrix. For Florida washer, this kind of method is one kind of shortest path algorithm. The thing is that it iterate the way it's doing is that it's trying to iterate every vertex. And also for every vertex, we iterate those kind of start and end. And for this one that we have, so what is that? If for every vertex, then for every start end. So if we have, for example, those kind of relationship, S and V, and relationship V and end, right? Start and end. Then that we can get the kind of relationship of S and V, right? So in this case, we can just write a code for this. We need to create a Boolean, just compose a Boolean for the relationship. First, new Boolean, number of courses and the number of courses. So for each courses, we try to find their relationship. So what we do is that for the prerequisite, we put those kind of relationship first. Then what we do is that we just use, for example, iterate every vertex. Then we do for int start equals 0, start smaller than, for int end equals 0 and smaller than this one and plus plus. So we'll say relationship start and well all equal to um, relationship start to E start to V, right? And relationship V to N. So in that case, we create a relationship matrix. And in the end, our result, we just check this table. And return result. One thing to notice is that we need to have this kind of for loop uh, at uh, outer layer, and for the start and end to be the inner for loop. Otherwise, it will be those kind of this order matters. If we put that inside, we may use some kind of unupdated values to update start and that will get things wrong. And also, Florid washer, this kind of algorithm, the time complexity is O vertex. It is, let's say, the time complexity will be O vertex power 3 time complexity. And we use Boolean relationship matrix. So that will be an O V power 2 space complexity. So we'll say for this question, if this is a dense graph, that means um, 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 that means we have those kind of n, right? So that means we those kind of vertices, they um what say this is good for dense graph, because in that case we can have use some small number of vertex to have this kind of graphs. So this is Florida washer, and so that means even the power 3 we can still accept that. For the Python code, it will be very similar. Let's write Python code as well. So we need to have let's say let's say relation both multiple by number closest for this one in range number closest. Right? So Let's put for P in prerequisites. We're going to have a relation P0, P1 equals true. And then we just iterate the kind of vertex. And for start in range, for end in range, then we're going to have a relation start end, well, all equal to relation start to E, right? So that means if we find a, a, a kernel path S is a prerequisite to V, and V is a prerequisite of N, then we're going to have S is a prerequisite of E, right? So then we just check this kind of metrics.